What's up, guys? We continue writing the DBML parser in C++. And before implementing other things that we talked about in the previous episode at the end, I would like to fix one issue that I found watching the previous episode myself. And it is with indexes. It might be with columns, but I'm really not sure because we implemented indexes last time, and that's where the problem might be. So if we go into parser and we go into consume index, there it is, and with settings. So here somewhere we have name and note, and as I copied the code because it's pretty much identical, I accidentally used, see here, index name. I assigned index name 2 times. So here it should be index node is this. Yes, and even if we go here and just build and then run it, now we get somewhere here this note its date, because previously we had this as displayed as name date, which was incorrect. Okay, so we fixed this. And the other thing I would really like to try to do is if we go into our, for example, table, and we have this long operator that prints into a stream, and it has a lot of actually repeated code. And I would like to somehow just make it into a function or lambda. I'm really not sure how you can, what you can do with those. Like, can you define a function inside a function and so on? But I'll just try. So we have those settings here. And we'll start somewhere here. I would say something like void print setting, and it might have few overrides because we might have settings of few different types. So we have Boolean settings. We have settings with setting with this value. I mean two, because we have a node and we have lists. And basically lists are just, they could be treated the same as this one, for example. So I need really few overrides for those. So here this, I'll just split it a bit. So here we say it can get just Boolean value, but actually no. So we can say just key, and it would basically do this, and then this. And so now we can say here print setting, and but it is only if it is true. So you say Boolean value. Here we would say this, now unique. And increment. Yes. What we have else? Default value, node, and refs and checks. So we say key, and here this one. And here I forgot, we need to wrap it. So if value, and only we do it. And here as well, so we say if value, then, and I would probably do something like maybe print comma and so this. Yes, and we also need just a string. We don't have to do this check. And probably what we can do is just move it here and basically say this. And here just use it. And here we should just print value, but here we say print setting key and value like this, and then we just here say what we have default value, right? So default and default value. Now we print refs, right? Refs, then checks, or no, where do we print node? We print node and then refs and checks. Maybe we should print node at the end. So let's print, say, for const auto ref refs. We this and here we just say check checks. And at the end we print setting note and column note, and this we can just comment like this. We can try to see if this works. So okay, so maybe we cannot do it. Maybe we should instead use lambdas. Let's try. So to convert it into lambda, what we do is here we say auto print comma is so we capture this need comma, the reference that we want to modify it, and we just have no arguments here, and we have to do this. Here we do basically the same, so say auto print setting equals, and here we how do we actually capture that we can call one lambda from another? Could we just do like this? Would it capture the pointer? Let's try. And here again, say auto print setting is, can we just capture this print comma, and here the same. Let's try. No. Out was not captured. Oh, right. All right. Really. And I cannot do it like this. Instead, I would have to define some structure with call operator with different overrides probably. Because I just reassign it, try to reassign it. So here we need also out, and here we need out, but it doesn't matter here. So let's maybe then try to do the next thing. Try step by step, comment this, and instead of printing settings, so we would just comment this as well. Even comment all of this. here remove comment, and we would define only this print setting as it is here. Print comma, yeah, print comma. And I would say this, and it basically just use it everywhere. I don't know, can I? Oh, I can repeat everything. Cool. That's super nice. It's super useful. Yes. Let's see if it works. Yep. Cool. So it works. I think what we might do is actually create some utility, because we have this behavior in two places, in index and in column, because there we have settings. So I think we might create a class structure, whatever, something like settings printer, like this, and we give it the output and give it has on this needs comma flag, and whenever we call it, it updates it and prints a comma if needed, and just prints the values as we described with those lambdas here. So maybe let's even try to implement it. Why not? Because we have index here, right? Check index. Yeah, we have the index here. So we have settings printer, and here we have private boolean need comma false by default, and we have some and here we would have and I would probably also need this print comma. So void print comma if print comma then, and as it's private, would add those prefixes. If need comma, then do this and set this. And now in public we have all those three methods. I may go down here and copy them. Yes, and indent, and here say print setting, We don't need any captures here. Yes, looks kind of good. Let's then try it. So here we say we would comment this one. So I would go like this. This we also don't need. And here like this. And instead we do settings printer, or we might want to let do print setting printer sp and give it out. Say sp print setting. You know, we may just go here and copy all of this. Just insert can I just now do do like this and copy also all of this. Yep, let's try it. No. And yeah, I have to everywhere substitute it. So we go here and here we say not this. Say substitute out with amount. Yep. Okay, what else? And yeah, we don't have inline ref because it's printed somehow else. So maybe instead what we would do is say now it's kind of like this. It's just repeated. We're just experimenting. And end comma, right? So here we go. Yes. And we need also some constructor here. Explicit enter. Yep. Yeah, it works. Cool. Maybe then we can just reuse it. I'm curious, could we, instead of this, use something else? So let's try template type name, and here we would say this. And maybe we would pass it as reference. Maybe not. Then we can just get rid of this. And actually, can I just move it? Too much. Okay, move it -7, 8. Yeah, it's 8. Cool. Just a bit. Separate them. So we got just value. We got optional, but here I guess it was actually okay to have a separate for string view because we don't want the reference, we want the copy. It's shipped to copy, and here it's we don't also need this because we don't have some such settings. So let's separate them a bit. It's okay, and yeah, so this is it. So here we can basically just erase all of this. Maybe we could even somehow make print settings for vector, but whatever. For now, let's do like this, and we can basically use it here in index as well. If it has any settings, here we say settings printer sp, give it out, and say what we have here. It's type and index type. Now it's primary key, so it's pk. Actually, it's not the primary key. It is an error because we don't have those. Pk and index primary key. Setting now it's unique, and name and node. Okay. Yes, and we can get rid of those. Yes. I'm curious, like, how to even make it more convenient. But it's okay for now, as it is. It's absolutely okay. And yeah, looks good. Let's try if it works. Yep. Cool. This is really good thing. The only what I would do is maybe move it into another file. So let's open it. Let me split it how I do it, like this. And here I want to create a new file and call it change here, go into table, and it's settings printer. Okay, and here I would just get all of this and paste it. And now we need a lot of imports. So what we need is these. And also we need this define guard. We say if not defined yeah, that's good. And we have to rename it. We exit here, we in a bit, and we also include settings printer. I would now rename it. Okay, this is good, and we want to make lists, and here say this, and I had to do this. Let's try. Yeah, cool. So this works. Now we have more convenient settings printing, not so manual. Let's then try to really implement next things, and I saw they updated the documentation a bit. So there is something about just the syntax itself, about enrichment and visualization, and just entities. I'm not sure about this. For me, when everything was just on one page, it was more convenient, because for now it just scatters around, like those settings and notes and stuff. Anyways, let's go here, and we need relationships. So it is here, those short form and long form things. So let's first of all then implement the ref structure. So we go into our ref here. We have inline ref, and we need just the ref. And what it has optional name. So optional name, and we need optional here. Right now, What else we need is, for now we would again omit schema. Instead we need a table name and list of columns and nothing else. I'm really thinking how to, because the straightforward option is to represent those two lists of columns with just two vectors, but they are essentially like one-to-one correspondence. So maybe to represent them as a vector of pairs, but probably not. It would be then tedious to first of construct this, because we would parse them for sure into two vectors of pairs. I mean, two vectors of just column names, because they are like, first columns of one table are all specified, then columns of the second table are specified. So instead, so what we would do, we would say string view left table name and vector, and then so we also need the vector here. And I'll just say left table and left columns. Now we have the kind. So kind, and now we have the same but for right. And that's it, actually. We would have to define this operator for it, but we would do it maybe before, maybe after we parse it. So let's write it and go into, by the way, can I open like this? All right, that's cool. So we don't have to open this Explorer thing. So let's go into here. Here we have table, and we would also add an extra thing and say else if what is ref. Then we say ref is consume ref and print it. Let's import this ref then here. And go where we have a lot of things. So we can delete this at the moment for sure. And this is column. We will go after it and say it is ref consume ref. And what we do is, so we consume again this first keyword, which is just ref. Then what we expect, it's either long form or short form. So we say we would have some boolean long form is false. So if pick is curly, token type curly open, then yeah, long form is true. Else if peak is token type colon, we say for now just this. So yes, and we consume it. And at the end, we would do if long form, then we consume token type curly close. Yes, and at the end we would return this ref, which we construct somewhere here. Say ref. Now we might have, oh yeah, this is incorrect because we have a name before the colon or bracket. So let's move it then here. We might have the name. So we say if peak is and we have something like this for project. Let's go into consume project. How we do it. So if it's a word or quoted, I'll just copy it and say if it's a word or quoted, we say ref name is this and consume. All right, and now we do this, and here we parse the body. So what we do is we get the table name, left table name, and it is a name. We just say ref left table is consume name. Now we consume token type dot, and we might have either trans or just one column. So if peak is token type run open, we do basically we do the same as in index. So let's go into consume index. So we can even copy probably it and go into here, just paste it and indent it. So if it's open, we consume the current open until it's closed. So we say if, and here we say ref left columns empty, consume comma. We don't have the expression, so we can just say this. The single column we just then and here is not index, it is ref left columns. Here we also delete all of this and say ref it's left columns. Now we consume the ref kind. So let's go into colon is, remember, just above us. So over here we have this ref, and here is it. Let's go. And I'll add a left table, left hand side. Here I would say relationship type or kind. Paste all of this, over it. Yes, and here I would say right hand side, and we would for sure have to abstract it because we repeat it a lot, but for now it's okay to just have them like this. And here we say right, and maybe we could just do like say this left with right, replace it. Yeah, and we're good. And relationship kind, so we say instead of this we say ref kind. Yes, and it's actually not even this. Oh, so we would be able to don't need this. We have already a kind in ref. Yeah, that's good. Looks good. And so yeah, nothing else here. And we handle this. The only thing is we have to check if those match. But I'm really not sure because I'm thinking we would have to implement validation for all of this for sure. The only thing is it would be like a third step. So the first step is to tokenize it. The second is to parse it. And the third is to validate it. And technically we can validate if those lengths match. But we cannot even validate if the columns are present, if tables exist, if columns exist. So for now, we would keep it as it is, and we would validate them at the third step, where we would validate all those relationships and that all the entities are correctly used and stuff. So for now, what else we need to do is let's open the ref. Yeah, we have to write it. And here let's implement the printing of it. So I'll just copy this line and this. Here what we do, we print ref, and I'm really curious, should we somehow store whether it was a long form or short form, or should we all print in You know what, we can actually store those. So let's say boolean form false. By the way, we would not be able to probably instantiate it because we don't have a default value for this, maybe. And for those, we'll see if it lets us do it. So it is ref. I only have we have the name. We have the name, so we can even move it a bit around. So ref. Now if ref name, then we print space and ref name. Now if ref long form, then we print curly, or we even print like this. And some indent. Else we just print the colon. Now we have to print this thing, like the body. So we print left table dot, and now if it has more than one, then we do this and say and else you just print the first item. Now we print space and the string ref kind and another space, and we would repeat all of this but for right. So here we substitute left with right. At the end we say if ref long form, then we just print this. And we return the out. Let's try to run it. And of course we get a lot of issues. And consume name probably returns a token. And so we go into parser. Yeah, it returns a token. So let's try to search for this usage. Yep. And here we say value. What else we got? Oh, a lot of things. Oh, ref name, yeah. So let's go here. Ref name is optional. We have only name is optional. So here we say value. Yeah. Now what we got? Yeah. This is ref 72. So here I've just forgot those. What else? And 86. Now oh yeah. So there is somewhere an error. It is in parser. Okay. So here it expects format string, and it actually started. And I don't know how to escape it. Can I escape it just like this? Or I should do it a bit different. Yeah, I can escape it like this. Now somewhere else, consume name, ref table 456. Again the value, and here we fixed it. Yes, we fixed it. Yeah, cool. Let's then try to add some of those. At least it built. So test DBML. Let's go at the end somewhere here, and let's add those. Yeah, we got an entity, but we have to make those small, because for now we are really case sensitive. So we got invalid relationship type. What we have here, this. Interesting. Maybe we didn't consume properly all of those. Let's go into parser, consume ref. So what we do, left hand side. So if it's print open, consume it, while consume name and consume this one, consume name, correct. So if it's left, if it's right, if it's dash, and then just let's print to string eq value kind. And we probably have to include token. Might be included. It's just a test. And token, it's not kind, it's type. Here, so type. So we've got some dot. Maybe I know what's the issue. The issue is that we have schemas here, and at the moment we don't support schemas anywhere. We would have to remove those like this. And I really want to also add a ref with multiple columns. So we would say even like this. And also I want to add this one. And what we need to print the new line. Yeah. Good. Yeah, we've got everything. Although, let's maybe not. Let's go into how we print it. Do we really print 2 times the left? So this is, let's say, left hand side, or of kind. Yeah, I just print. Should be right table. Yeah, so table 1, table 2, column 1, column 2. And yeah, we don't anyhow parse the long form. So let's fix it. We go into Parser. Let's search for this. And we say ref long form is true. And just at the end, if ref long form. Yeah, it works. Cool. That's super good. That's super good. We managed to parse the refs. Now, what we might do next is actually we have a lot of options here. There are still a lot of things to implement. So we have partial tables, something here. It's table partial. And it has even some table settings, but it's only header color, I believe. So we won't bother about it at the moment. Columns, and you can insert those somewhere. And we have to preserve the order as well. We have to basically like, that's interesting. It's actually interesting because what I'm thinking is we might change a bit how we store, for example, table. Instead of just having one vector of indexes, one vector of checks at the end, we might want to have this variant. So table is basically a list of variants, and each variant is either column, block of indexes, block of checks, or partial as it is here. So, but for now, we keep it as it is. What instead we might want to do is really to, at this moment, implement schemas. This we probably can no longer postpone it. This is really important from other things we have here, because other things like those partial tables, like some, what else we have here? Table settings, customization, sticky notes, table groups, and stuff. This is kind of very optional, but schemas are really crucial. Yes, so we might start it right now, but I'm not sure how far we can get, because we have to do it in a lot of places. So in table definition, here we might prepend the table name with schema name. In what we have, columns, when we have refs inside them as well. Then in what? In refs. Maybe not so much, not so many places actually. The only thing is how to check if it, what is a schema and what is we have string. What I'm thinking is, for example, we have refs, and here in the we have like 3 parts of the name, and basically what we have to do is we have to somehow check ahead if we have like 2 names and then we have the column, or those paren open. Yeah, this is interesting. This is interesting, and I'm really thinking that we might do it in the next episode. Let me check the time. Yeah, so in this episode is over an hour right now. So this might be it for now, what we did today. And schemas, we would move it really to the next one, because I guess it really might take quite a while. And also there are other like maybe small refactorings I would like to do. So it would be in the next episode. We would concentrate on schemas solely. So this is it. And today what we implemented is refs, and also we implemented a really cool thing, settings printer, which really takes all this boilerplate code for printing settings, all this repeated thing, and instead just extracts it, and we can use it, for example, in here, just like this. So printing settings just went down to this from, remember, those maybe 100 lines of code, and we reuse it for index as well, for index settings here, which is even simpler. We don't have any vectors collections. So this is really cool. And also, of course, we implemented the references, and even preserved whether they are long form or short form, names, tables, and stuff. Some code, not some, but a lot of code repeats, because left-hand side and right-hand side of relationship is the same. Basically, it parses in the same way, and it's printed the same way. Maybe we would have to somehow abstract it, make some function for those to not make them repeatable, but for now we keep it as it is. We keep it as it is. And yeah, so this is what we've done today. Pretty good job. Parsed another entity. And as I said, the next we would move to implementing schemas. So that's it. Like, subscribe, share, you know what to do, and see you in the next one.